Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Echo Chamber by Allegem, or Allegem. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have cave shading, where we need to shade some cells in the grid such that all unshaded cave cells are orthogonally connected, and all shaded wall cells are orthogonally connected to the edge of the grid. And no 2x2 is fully shaded or unshaded. So as an example, what could we do? This could be a valid shading because, I mean, we could do something like this too, so that's fine. Or we could do something like that and that. So this is an example of a valid shading because the shaded cells are all orthogonally connected. And what does it mean to be orthogonally connected for all shaded cells? It means you can go from any shaded cell to any other shaded cell just by going through edges, all while staying within the region. So to get from this cell to this cell, you could go this way, going around, and it just goes through edges, all while staying within the region. Cave cells, though, have to be orthogonally connected to the edge of the grid, which means you have to go through edges to a cell that's on the edge of the grid. So therefore, this is valid as a cave or as a wall because it can orthogonally connect, which means going through edges, all while staying within the wall cells, going to the edge of the grid. And so was this. What would not be valid would be something like if we had a shading like that. Because this section of wall cannot orthogonally connect to the edge of the grid. And this is also not valid too. Because again, to get to this wall section cannot get to the edge of the grid just by going through edges. It has to go through a corner or go through a cave, which is the shaded section to do that. And this wouldn't work either because we have a 2x2 area that's all shaded, which is not allowed. And if we tried to also do something along the lines of this would not be valid for multiple reasons because this 2x2 area is unshaded and this 2x2 area is shaded. So that would obviously not work. And those are examples of how cave shading works. We have counting wall sweeper circles. A digit in a circle indicates how many circles contain that digit. So for example, if we had, say, a 3 here, that means 3 circles total would have to contain a 3. So you could have a 3 here, and then a 3 here, and then we would have no other 3s in the circles, because we already have 3 3s in the circles. So that's how counting circles work. And a digit in the circle also counts the number of shaded... Wait. Oh, I did it the wrong way around. Okay, so shaded cells are wall cells, and cave cells are unshaded. Apologies for that. So then I guess we make this green, right? And then the wall cells are shaded. We'll make those blue. Okay. A digit in a circle also counts the number of shaded wall cells in the surrounding 3x3 area, not including itself. So this cell would count the number of shaded cells, not including itself. So this would have to be 2. Well, in this case, this would also have to be 2. This would also have to be 2 because it doesn't include itself. This would see 1, 2, 3, 4, 5, 6, 7. So this cell would have to be 7. This sees 1, 2, 3, 4, 5. So that would be 5. This sees 6 walls there. So that would be 6, etc., etc. So that signifies how many of the circles, the digits in circles also signifies how many wall cells or shaded cells are in the 3x3 area centered on that circle. So that's how the counting wall sweeper circles work in total, or those are examples of it. And finally, we have cave sums, where a small number in the corner of a cell gives the sum of all digits seen orthogonally from that cell, including itself, where cells of the opposite shading block vision. Wait, but it doesn't say that it has to be a wall, or it can't be a wall, right? So obviously this is going to have problems because orthogonally it only sees these 2 cells. It doesn't see any other cells. This cell could only see these 7, and those 7 of them would have to add up to 29 because it's blocked by opposite shading from vision. So it cannot see that, it cannot see that. This would have to have all 6 of these cells adding up to 20. This would have to have all 5 of these adding up to 20. It could not include these. This would have to have all of these cells add up to 14, so obviously there's an issue there. And it must include itself too. It doesn't say anything that it has to be part of the cave. So that's not necessarily given. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the corner cells are interesting. You can have, so you can't count itself as a wall. So that means this is up to 3. But if we have 3 ever as a wall, the problem is that therefore these 3 would be a wall, but then this would have to be non-wall because you can't have a 2x2 area that's fully shaded. But then this cave section would not be orthogonally connected to the rest of the cave cells in that case. So this can never be 3, which means it has to be 1 or 2. And 1 can only appear once in the circles, so it can't be 1 here, which would force that to be 2, which would force that to be 1, because we have 2 1s then in these circles. So this must be 1, this must be 2, and this must be 1. Interesting. How many other digits do we have in the circles? We have 1, 2, so 3, 6, 8, 10, 12, 13, 15, 17. Oh wait, did I include these? Hold up. Let's just not count the 1s and 2s. So 1, 4, 6, 8, 10, 11, 13, 15 more. 15 more. And we don't... Wait, that's wrong. How did I get 1, 2? These are, again, 2 and 1. That was weird. For 2, it could be 2 that way. That is possible. Again, 1, 2, 5, 7, 9, 11, 13, 15 more. We have 3 unique digits adding up to that. And you can't have 1 and 2 anymore. So it's 3, 4, 8 possible to add up to 15. 3, 5, 7 or 4, 5, 6. So in the circles, we have 3 through 8, right? And obviously you can't count itself for walls. And you can't have 8 surrounding a circle because then it would be blocked in, and that would have to be a cave. And then they would be orthogonally connected to... So this cannot be 8. You cannot have 8. So it's not 3, 4, and 8. So it's either 3, 5, 7 or 4, 5, 6. You're guaranteed a 5 in them. Huh. Okay. So it's 3, 5, 7 or 4, 5, 6 adding up to the remaining 15. We're guaranteed a 5 here because all 3 digits are there. We're guaranteed a 5 here because all 3 digits are there. Other than that, though, I don't think we really have any guarantees. What happens if it's 7? So, you could have 7 doing something like this. That is possible. Huh. Oh, this can't be... This is up to 5. Because it's on the edge. This is up to 5. It's on the edge. Can it be 5, though, on the edge? I don't think so, right? If it's 5 on the edge, that means all of these must be cave. Or sorry, all of these must be wall. And therefore, you have a cave here. Because you can't have 2 by 2 area that's all shaded or all unshaded. And that would be all shaded here. But then the cave would not be orthogonally connected to the rest of the cave cells. So this cannot be 5 here. Same with this. This cannot be 5 here. And therefore, this cannot be 3 or 4. It's one of them's guaranteed to be 5, and one of them has to be 6 or 7. Okay. So this has to have 3 or 4 walls. At most, one of these is shaded or unshaded. So it could do something like that, if this is 4. Hmm. One of these is 5. Hmm. So if this is 4, let's try. Then one of these is guaranteed to be unshaded. Therefore, all of these must be shaded. Since that's shaded, this must be unshaded. One of these is shaded. If this is shaded, that can't orthogonally connect to the rest of the unshaded cells. So then this would have to be shaded. You'd have to orthogonally connect to the unshaded, so that would go that way. That seems fine. This has to be 5 and 6 then, if that's the case. We have 3 here. This would then have to be 4 also. We don't know where the shading is here. So then this would be 4, 5, or 6. 4, 5, or 6. 4, 5, or 6. Okay. 5 and 6 is a pair. One of these two has to be unshaded. So this cannot be 4, 5, 6. It's 2, 3, 7, 8, and 9 here. That seems fine. Let's see. Obviously, this can't be 4. Could do something like this. Could be something like that. Could be something like that. Could even... Cannot do something like... Okay. So I think this has to be shaded, right? If this is unshaded... Sorry, this has to be unshaded. If this were shaded... The problem is, if this was shaded, you'd have 3 cells at least in one of these 2 by 2 areas being shaded, which would mean you'd have 4 shaded. So this has to be unshaded in this instance, which means it cannot be 4 shaded that way because that's not orthogonally connecting to the rest of the shaded. So this is shaded here, shaded here. 2, 3, 4, and 5. So this cannot be shaded in that instance, because if it were shaded, you see at least 5 cells. This is 2, 3 at minimum, 4 at minimum, 5 at minimum, which is already 14, and you'd have another digit here. So this has to be green going that way. This sees 5 or 6 cells that are shaded. This sees 5 or 6 cells that are shaded. I mean, it's looking like this could be the case. Maybe. Let's take a look at 3, 5, and 7 as possibilities. So, what happens? So this cannot be 3 or 4, because this has to be the low digit here, guaranteed. Again, you can't have 8 in surrounding a circle because it would be all walled off and it would be a cave cell. So what happens if we have 3, 5, and 7? 3. This would be 5 or 7. Okay. How many 7s do we have? We only have available 1, 2, 3, 4, 5, 6, and 7 in these rows. So this would have to be 7, which means this could not be 7. So this would have to be 7 here, which makes this 5. This has to be 7 there. So this cannot be 7, and we have a contradiction. Because we need a 7 here, 2, 3, 4, 5, and 6 only that has available for being 7. So it cannot be 3, 5, and 7. So the way that we were going was correct. So this has to be 4. So we can remove 3 and 7 in the rest of the boxes. This has to be 4. And this must be 5, 6 as a pair. So everything that we were doing was correct. This is 4. This is not 7. So if this were... So one of these is 6. One of these... So we have 1, 6 here, 1, 6 here. So either this is 6, I believe, which would make that not 6. Well, this doesn't have to be 6. Anyways, this has to work this way, as I said. So this is blue. We have green here. Green has to go out here. These must be blue, because this must be green. This cannot be blue here. So this has to be green. We have 2, 3, 7, 8, 9 here. So this could be something like 2, 3, and 4, 5. Or if it's 3 digits adding, so this is, You could have, can you ever have 9 here? 2 and 9 with 3 adds up to 14, but this can't be 3. It's 4, 5, or 6. So it cannot be 2 and 9. It could be 2 and 8. Could be 2 and 7. Could be 3 and 7 here. Or it could be 2, 3, 4, 5. We don't know. Remaining digits in row 2. 1, so no 1 here. This is 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. No 2 here. 1, 3, 7, 8, 9 there. So yeah, it's not necessarily the cave. This is a wall, right? So, we have a 6 guaranteed here. Huh. Remaining digits in column 3. 1, 2, 3, 7, 8, 9. Obviously no 2 here. What else do we have? So if this is all blue, that's 2, 3, 4, 5. Okay, so this is 1, 2, 3 already, plus 4. One out of these two has to be green, at least. So that's 1, 2. So if this is 6, okay, let's try that. So if this is 6, this is 5. One of these has to be green, at least. If this is 6, one of these is green. The rest of this must be blue. So this must be green. That would be green, but this would then be blue. So the problem is this would see 1, 2, 3, 4, 5, 6. So this can't be 6. Therefore, this has to be 5. So this is 5, which makes that 6. Interesting. This has to exit out. Because either this is blue, which means it exit outs anyways, or this part is blue, and this is green. So this is green, which would force this to be blue, which means it still must exit out. So it must exit out, period, anyways. I guess it could exit out this way. So this is always then green. You could potentially exit out that way. I guess let's try that. So what happens if we go that way? This is 1, 2, 3. These would both be blue. We have to exit out. Yeah, this would be 1, 2, 3, 4, 5, 6. So either way, it exit outs this way or this way. This is blue because we need one green and one blue here. So if it goes this way, then we'd have blue, blue, blue here. This has to go to green there. Right, so we know this is 5, that's 6, which means this cannot be 6. It can't be 5. So, in boxes, in one of these is a 6. One of these is a 6. So one of these can be a 6. One of these can be a 6. That's 2. One of these can be a 6. That's 3. One of these is 6. That's 4. Therefore, we have to have a 6 here. Right? Because 1 here, 2 here, 3 here, 4 here, and then this is the 5th, so we need a 6th one here. So this is 6. Okay. This is green again. This is blue. So, okay, if we tried going this way, then this has to be blue. But then this sees has to have 5 cells, not including itself, be blue. And then they would have a 2x2 area, which would be all blue here, because these would have to be all blue. So it cannot go that way. So it does have to go this way. So it goes through here. The rest of these are all blue. So this has to go out to here as green. 4, 5, or 6. So this sees 1, 2, and 3 already. This also sees 1, 2, and 3. We have to have some green here in one of these two cells, one of these two cells, one of these two cells, and one of those two cells. Hmm. So we have to have a 6 between one of these two. Same here, it's one of those two. 6 can't be here, 6 can't be here. We need a 6 in one of those two. So we're missing 6 in the rest of row 9. And we are missing a 6 in 1 out of 4 and 6. And we're missing a 6 in 1 out of row 1. So the remaining digits in row 1 are 3, 5, 6, 7, 8, 9. No 6 here because 6 in the box. No 6 here because of 6 in the column. 1, 2, 3, 4. Right, we don't know. Okay. What happens here? So if we do the full blue, that would mean this has to be green, this has to be green, this must go out as green. This would then be 4 and 5. So this would have to be 4. Because it sees as 4 walls there. This would be 5. That would be 6 there. This has to see 5. This is green then. This is blue. So green has to go out again. Green has to go out. This sees at least 4. So far that's working fine. Oh, but this has to be blue, and that's too large. So it'd be too large of a sum because it adds up to 14. And that can only be 2, 3, 4, 5 at maximum digits. So, therefore, it cannot go 3. This is green then. So this is green. So this has to be 1 out of 2 or 3. So 2, 8, and 4 work. 2, 7, and 5 work to add up to 14. 3, 7, and 4 work. So this has to be 4 or 5. This is 3. If this were 5, say this was a 5 here, then this would be, we have blue, 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 so this would have to be blue here and blue here. Green has to go out. This would have to be 6. This would be 4, that would be 5. 6 would eliminate 6 here, so this would be 4. And then we'd have a problem because we already have the 4 walls, so these cannot be walls. That would be green, but then if this is blue, this 2x2 area is all blue. If this is green, this 2x2 area is all green, and that fails. So this can never be 5 here. This has to be 4. So again, it's 2, 8 with 4 or 3, 7 with 4. 4 cannot be here. 4 cannot be here. I think the problem is if we have, well, maybe not. 5 and 6. So how many 5s do we have? We have 1, 2, 3, 4, 5, and 6 possibilities. So if this is a 5, that means neither of these could be 5. This couldn't be 5 anyways. We have 3 4s already here. So again, this is 2, 8 or 3, 7. Adding up to 10 with 4 is 14. This is green. The problem here we ran into... Okay, so what if this is the blue? Then obviously this couldn't be 4 for the same problem that we had earlier. So this would have to be 6, which would force this to be 5 and this to be 6. Okay, so does that... This is green. Not blue. This is green because of the 2x2 area that is already blue, which has 3 blues. So 6. We have 2 here, which are green. 5. We have 4 here. I mean, it's looking okay. Okay. This can't be 4 because of 4 in the column. This is tricky. This can't be 4. One of these is blue, but this one's an easier sell if that's blue. So 1 out of these 2 is blue, which means 1 out of these 3, or it could be 2 out of these 3 if this is 6. So let's try if this is 6. If this is 6, this is 4, this is 5. Again, you cannot have blue here because then this would be a problematic scenario. But what happens if we have 4 here in general, right? At most, 1 out of these is blue. You could have technically 3 blues there. That actually does work. And then you have green, green. This is 5. This is 4 in that scenario. Only 1 of these can be blue at most. Could be green, green. That looks like it kind of works. No 4 here. Oh, we have 5 4s. Not allowed. Because we can only have 4 4s in the counting box. So. This cannot be 6. This has to be 5. So that's 5. This is 6. We have 2 5s here then. Okay, this 6 eliminates 6 from being here. So we have a 6 here. 1, 2, 3, 4, 5. This can't be 6. So this has to be 6 down here. So this is 6. One of these is 6. One of these is 6. So 6 cannot be here. 6 cannot be here. We have to have one of these be a 6 here in box 4. Therefore, this can't be 6 either. One of these 3 in row 1 has to be a 6 here. We are guaranteed... Well, it could have 6 here and 6 here. That could be the case. We have only 1 4 left in the rest of the circles. We don't know where. 5. 1 out of these 2 is blue, because we have 3 blues currently. Therefore, only 1 out of these 3 is blue. Okay. I don't know what it looks like to be 6, though. That's the problem. I think corners could be that possible, right? You could have something like that shape for the walls. I have a feeling this can't be 4, but maybe I don't know if that's correct. Okay, where 4 in row 3? It has to be one of these 3. 4 in column 2 is one of those 2. Either this is green, which makes that green, and this is blue. Or this is blue, which makes that green. And you could exit out that way. Oh. How? What happens if this is blue? If this is blue, this is green, it has to exit out. We also, okay, so one thing we do know is this can't be 2 here. So, where is 2 in row 2? Can't be here because of 2 in the box. Can't be here because of 2 in the column. So either this is 2, 8, or this is 2 here, which means this can't be 8. If this were 8, that would force this to have a 2, but then that wouldn't add up to 14. Because that 8 would be there. So 2 is one of these 2, or it's here. Remaining digits in box 1 are 2, 3, 5, 7, 8, 9. Again, we can't have 2 here, so and this can't be 8 because of the same problem. If this is 8, where's 2? It has to be here, but then it has to add up with 8 to add up to 4, with 4 to add up to 14. So that doesn't work, if that's the case. We're trying if this was blue. So if this is blue, this is green, it has to exit out. The problem is, if we just go straight out here, then this is already not going to satisfy the 6. And if we try to do some weird thing, go out this way, it also is not going to satisfy that, because it has to connect to the rest of the green cells. So this cannot be blue. This cannot be green here. It has to be, sorry, can't be blue here. It has to be green, which makes this blue. So then this adds up to 20. It has to go here. That makes this green here. It has to connect out. So this must go green here. I mean, I guess it could connect out this way. No. So if we try to exit out this way, the problem with that is this would have to be blue because we have already 2 cells which don't have a... Hold up. That actually could work. Well, no. Okay, so say this was blue. If this was blue, how does this exit out? It has to go green, and then this problem is it has to orthogonally connect to the rest of the green. This blue would necessarily be trapped, not connecting to the edge of the grid. So that's why this can't be blue. This must be green. Since these 2 are green, the rest of this box must be blue, because we have to have 6 wall cells around the circle, and we have 2 missing, so therefore the rest are 6. And therefore, this 2x2 area is blue, so this can't be blue, it's green. So this adds up to 20 here for these 5 cells. Okay. This sees 2. That's the reason why this had to be green. So this is satisfied. This is satisfied with 1, 4. We don't know anything about this. Hmm. This is already missing 2. And so if this were 6, that does not work. So if this was 6, we have 2 already missing. The rest must be blue. And then this does not orthogonally connect to the rest of the cave cells. So this has to be 5. This is 5, which makes this 6, because we have to have a 6 remaining in each of the pairs. So these pair, this pair, right? We have 1, 2, 3, 4, 5. This can't be 6, so this is 6 there. Okay, so I was right about that being a 6. So 6 cannot be either of these cells, which means this can't be 6 either. So this has to be 6 here. 5 cannot appear in this box because of 5 in the box. Okay. So to go through, the problem is, so say we tried to go green, green here. This would only have 4 walls in it, so it cannot go green, green. Green, green also has a problem because the 2x2 area, it's all green. So this can't be green, period. So it has to be green here, and it must go through here. Or it could go here. So it's one of these two exiting out, and the rest is blue. So that's blue. This is 5. This adds up to 20. So remaining digits in row or column 1. 3, 5, 6, 7, 8, 9. 3, 5, 6, 7, 8, 9. No 5 here, no 5 here, no 6 here. No 5 here because of 5 in the row. No 5 here because of 5 in the box. So, can you ever have a 9 here? I think the answer to that is no, right? Actually, maybe you could. 3, 5, and 9 could be with 1. Okay, yeah, that could work. 2, 3, 5, and 9 add up to 19 plus 1 does add up to 20. So you could have a 9 here. What's the maximum this could be? We have 2, 3, 5, and 6 at minimum here. So 2, 3, 5, 6, 2, 5, 2, 3, 6. 3, 5, 6 adds up to 14 plus 2, which make this a 4 at most. So this can't be 4, it's 1, 2, or 3. We have 3 4s. We have 1 more 4 here and 2 5s. So this has to have 6. This is blue. Oh, we don't... Yes, this has to be blue. So this 2x2 area has all blues, 3 blues, so this must be green. Interesting. Can we go green here? Well, that's interesting. What happens if that happens? So go green here, green this way, because this would be blue, right? We have 1, 2, 3, 4, 5. It cannot go that way. Can you have 5 digits adding up to 20 with a 5? Maybe without a 6. So the other 4 digits must add up to 15. Without 6. Maybe. I don't know. Where's 5 in box 5? It has to be one of these two. 4 can't be here, 4 can't be here. Remaining digits in column 4. 1, 2, 3, 7, 8, 9. Okay, this can't be 2. So again, if it went this way, and this can't be blue, I guess you could have a green here. You don't actually have to stop here. Interesting. That seems okay. Okay, what can we have here? If this were blue, that would force this to be green because of the 2x2 box. Then these would have to both be blue, and that wouldn't work because this green would not be able to orthogonally connect to the rest of the cave. So this has to be green. Interesting. Could be blue here. Could be blue here. Cannot be blue that way. So if we try to have blue going this way, this can't orthogonally connect to the rest of the cells. So if we try to make that green, that doesn't work. This is blue also. Interesting. Huh. So this is blue, which makes the rest of these green. Since the rest of this is a 2x2 area that has 3 greens, this can't be green, that's blue, which makes that the 4 blues there. So this can't be blue, that's green. That's orthogonally connected. These are 2 greens, therefore these are blue. That's 6 blues there. This has to orthogonally connect to the rest of the greens. That's interesting. This is 29. It could go blue there. It can't go the full blue there, but it doesn't need more than that, right? Okay. So again, this has 4 walls. 1, 6, 5, 4, 2, 6. 1, 2, 3, 4. And one of these is 5. 6. 4 walls. 1, 2, 3, 4, 5. Only one of these can be green. One of these has to be green. The other one has to be blue. So that's 1 green, 1 blue. You could go green, green out. Oh, interesting. So, how does this connect, right? Only 2 of the edges can be green around this. So it could be 1, 2, 1, 2, right? So the rest of them have to be blue. So this is, if we tried going green here, that doesn't work because that's blue. Can't connect. This would be green, green, green. The rest would have to be blue, and this would not orthogonally connect. So this is green, which makes this blue for the 2x2 area. Either goes green here, or it's green, green here. So the rest of this is blue. This is a 2x2 area, which is all blue, so this can't be blue, that's green. If this could go green, green if this is blue that way. So that's fine. One of these is green, one of these is blue. This is 2 walls here. We have 6 here. You could go do something like this, right? That is possible. Or you could go straight through. So if you go this way, it has to do something like that or go straight through. If you go this way... So this could be something like 5, 7, 8, and 9. Oh, hold up. We have 1, 2, 3. Okay. So this is 1, 2, 3 guaranteed, not walls. We have 1, 2 here. If it goes this way, this is 4. If it goes this way, it's 4, right? Actually, it can't go this way. It can't. So if it goes this way, so it can't. Both of these cannot be green. So, but if it tries to, so if it goes either that way or that way to connect orthogonally to the rest of the greens. So if we go this way, none of these are walls. So we only have 3 walls this could be, which can't be the case. So this has to be 4. It has to go through here. So then this has to go green, green. These are both walls. This is a 2x2 area, which is all blue. So this is green here. Green has to orthogonally connect there. This has to go that way, connect to the 6. And it could connect to here. So it either connects here or here. That gives us 2 cells that aren't walls in the 8 cells surrounding. So the rest have to be walls. So this is wall, this is wall. It could go this way and go around or go around. So I think either way this has to go around. If it goes this way, that's blocked here and it has to connect out here. If this is blocked, this still has to connect out here. So it still has to go here. So this is still green, green. So again, if this is blocked here, this is green. This has to connect to the orthogonally to the rest of the greens. So it has to go out there that way anyways. If it connects here, it still has to go out to orthogonally connect that way. So, okay. That's 1, 2, 3 blues for this 6. If this is blue, this would have to be green because of the 2x2 area, which has 3 blues. But that would be the last green possible for this 5, and that would have to be blue, and then the greens would not orthogonally connect. So this cannot be blue, it's green. That's interesting. Okay. This is 20. Ooh. Huh. So if it orthogonally connected here, so say this was blue, that makes this... Oh, okay. We've already got something else here. These are 4 digits adding up to 29, and they're all unique, so it has to be 5, 7, 8, 9. So this is 5. Oh, this is the last 4 in a circle, so this can't be 4. It's 5. That's 5. This is 7, 8, and 9 remaining for this cave sum. So that eliminates 7, 8, 9 in the rest of the column. This can't be 7, 8, or 9. It's 3. This can't be 3, 7, or 9. That leaves this as 1, 2, 4 here. So 4 has to be one of these 2 digits here. And we have to have a 4 here. This can't be 4 because of 4 in the row, so that leaves this as a 4 there. Sixes. Do we have any information there? 6 eliminates 6 here, so this must be 6 here. That's interesting. This can no longer be 9 with it, right? 2, 3, 6, 9 already adds up to 20. So this cannot have a 9. 2, 3, 6, 8 does work though, so that's fine. This has 5 cells that cannot be, that have to be wall. We have 1, 2 here. We have 2 missing here. This is the missing wall here, so these must all be walls. So these are all walls. That makes that green. Okay, so that's connected here. This is a 2x2 area that has 3 blues, so this is green. This must go out this way is green. Green has to connect, so that connects there. We have 2 cells here, which are not walls. You have to connect to the green, and we only have 1 green available in the rest of the cells. So it can't go down here, can't go here because that's diagonal, so it has to go green, green. So the rest of these are blue. Okay. And this is the cave shading. So now the rest is filling in the 20, the sums, and figuring out what those can be. Okay. We have 4 digits adding up to 20. They're all unique. Here, this is 6 digits adding up to 20. Okay, where we have 8 sixes, I believe, right? 1, 2, 3, 4, 5, 6, 7, 8. Yep, we know where the last 6 has to be. It has to be there. Remaining digits in this green section. Let's do that first. 1, 3, 4, 5, 7, 8, 9, and 6. No, 6 can't be there. 1, 3, 4, 5, 7, 8, 9. This can't be 5. This can't be 4. No 4, 5. No 5. I'm pretty sure you can't have a 9 here. So, 9 plus 1, 3, and 4 here already adds up to, so 1, 3, 4, and 9. So you cannot have 2 here, because if you have 2 here, this has to be 1, 3, 4, 5 at minimum. Okay, yeah. So this is 1, 3, 4, 5 at minimum. That adds up to 13. 13 plus 6 is 19. So this is the minimum here, 1, 3, 4, 5, which means this is 6, and this has to be another 1. So this has to be 1 here, and this must be 1, 3, 4, 5, cannot be 1 here, so 1 has to be here. So this must be 3, 4, and 5. And this can't be, no 4 and 5 here, so that's 3. This can't be 3 or 5, so it's 4. This can't be 3 or 4, it's 5. That eliminates 1 and 3 in the rest of the column. So we have 1 here, 1 here. Where's the 1 in column 7? Can't be here because the 1's in the boxes, so it has to be here. So this is 1, which makes this 2. That leaves this as not 2 and 8, it's 3 and 7, adding up to 14. So no 3, 7 in the rest of the row. And box, so this can't be 3, 7, no 3, 7, no 3, 7. Where is the 2 in box 1? It has to be here. So this is 2, this cannot be 2 or 3. No 3 here, no 3 here, no 3 here. No 2 here, this is 1, 4 as a pair, which eliminates 1 and 4 in the rest of the box. Okay. No 1 here because of 1 in the row. No 3 here because of 3 in the row. This can't be 2 because of 2 in the column, so this is 1. So therefore, 1, 6, and 2 add up to 9. So the remaining digits add up to 11, and it has to be 3, 8 as a pair. So this is 3, 8. That eliminates 3 and 8 in the rest of the column. This can't be 8. This is 9, which makes this 8. This can't be 8 or 9. It's 5. This can't be 3, 8, or 9. It's 7. So 5 and 9 eliminate 5 and 9 here, so it's 8. That means this can't be 8 here. No 8 here because of 8 in the row. This can't be 3 or 8 because of 3, 8 pair in the box. So this is 1, 7, 9 as a triplet, which eliminates 1, 7, 9 in the rest of the column. This can't be 7. This is 3, which eliminates 3 here, so it's 7. This can't be 179. It's 2, 8 as a pair. And we don't know which one's which. Remaining digits in box 7 are 4 and 5. This can't be 5 because of 5 in the row. So this is 4, which makes this 5. This can't be 1 because of 1 in the row. Remaining digits in column 2 are 3 and 9. Okay. No 1 here because of 1 in the row. Where is 1 in box 5? Can't be here because of 1 in the row. Can't be here because of 1 in the row. This has to be 7, 8, 9 to add up to 29, and this is not a 1, so this has to be 1 here. That means 1 cannot be here. This is 7, 8, 9 as a triplet in box 2, which eliminates 7 and 9 in the rest of the box. So this can't be 7, 8, 9. It's 1. This 4 eliminates 4. Actually, none of these can be 4. 5 eliminates 5 here. We have a 7, 9 pair in row 1, which eliminates 7, 9 in the rest of the row. This can't be 7 or 9. It's 5. So I think we've done all the we haven't done this sum yet. Okay, so that's probably important. Remaining digits in column 5. We have 2, 3, 7, 8, 9. Okay, this can't be 2 because of 2 in the row. Okay. This 7 eliminates 7 here. Where's 2 in row 4? Where's 3 in row 4? Cannot be here because of 3 in the box. This can't be here because 3 in the column. These are filled out, so this has to be 3 here. So that's 3, which makes this 9. That means we have 2, 8, 9 remaining in row 4. And we're guaranteed a 2 here. That leaves this as 7, 8, 9, with 7 having to be one of these 2 digits here. So this cannot be 7 here. This is adding up to 20. So we just have to add this up. Okay. This is 5. So can we have this without a 3? 5 plus 7 and 8 already adds up to 20. So no, 3 has to be here. So this is 3, which eliminates 3 in the rest of the box. What's the minimum here, actually? 3, 7, 5, 1, 2. So if this were 7, you'd guaranteed have 2 out of 7, 8, or 9 here, which would mean that it's at least 20. So this can't be 7, 8, or 9. It's 2, which eliminates 2 in the rest of the column. So we have an 8, 9 pair now in box 5, which eliminates 8 and 9 in the rest of the box. This can't be 8 or 9. It's 7. This can't be 7, 8, or 9. It's 3. This can't be 3, 7, 8, 9. So it's 2. Which means this can't be 2. That's 8, which means this can't be 8. That's 2. Again, 2 cannot be either of these. 3 cannot be here anymore. So 3 has to be here. So we have 10 here. So these 2 digits must add up to 10. Well, you can't have 4 and 6 here, so this must be 1 and 9. So we have 1 and 9 here, which makes this 4. And this can't be 1 or 9. It's 7, which eliminates 7 here, so that's 9, which eliminates 7 and 9 here, so that's 1. This can't be 9 here and here. This is 7, 8 as a pair, which this 9 eliminates 9 here, so that's 8. Which eliminates 8 here, so that's 9. This can't be 7 or 9, it's 8. This can't be 8 or 9, it's 7. 7 eliminates 7 here, so it's 9, and that's 7. No more 9 here, no more 8 here. Okay, so we've done all the sums. So now we just have to do Sudoku. 7 eliminates 7 here, so this is 9 and 7. Remaining digits of row 9, 4 and 8. 4 can't be here because of 4 in the column, so this is 8, that's 4. 8 eliminates 8 here, so it's 2 and 8. Um, how many ones do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Twos, we should have 8 twos. 1, 2, 3, 4, 5, 6, 7, 8. Yep, we know where the last 2 is. It's here. Threes. In column 8, the 3 has to be here. And we don't know much about the rest. So fours. 1, 2, 3, 4, 5, 6, 7, 8, and 9 with 9 fours. 1, 2, 3, 4, 5, 6, 7, 8, 9 fives. 1, 2, 3, 4, 5, 6, 7, 8, 9 sixes. Where's 7 in column 9? It has to be here. So that's 7, which means this can't be 7. That's 8 and 7. 8 eliminates 8 here, so it's 3 and 8. Okay. And that should give, so we have 8 sevens, we need, or 9 sevens. How many 8s? We have 9 8s, and 9s are the rest. So 9 in column, we have 9 in column 9, has to be here. And 9 in column 7, we have 8 9s now. We know where the last 9 is. It's here, which forces this to be 3. Congratulations, your solution is correct. Did you realize the entire cave shading in this puzzle is forced by the circles alone? Yeah, actually I did. Yeah. The cave sums were only needed to disambiguate the 3s, 7s, 8s, and 9s. Thank you for solving. I did use some cave sums, like this one, right? So maybe I didn't realize that completely. Yeah, I don't know if I completely realized that, but it did seem like it was being forced a lot by the circles. That was interesting. But I did use some of the cave sums, particularly here, to determine where the shading was there. Maybe that was a shortcut. This one I was forced specifically by that circle, so that was pretty forced there. So the only one where I used potentially cave sums was this one. Everything else was basically pretty much derived from these circles, as Allegem said, or Allegem. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.